Hi everybody, Captain Al speaking with your training tips designed to help make you a better, more knowledgeable flight simmer, pilot, or aviation enthusiast. Have a seat, let's strap in and stow the HUD and see what is on the horizon for today. Our briefing today will cover the safety check, or sometimes known as the electrical power-up procedure. And then following that, we'll do the preliminary pre-flight procedure. The electrical power-up procedure is the name that Boeing gives it in order to establish AC power from a cold and dark airplane. For subsonic flight training, I call it the safety check because it's a check that's done to make sure items are safe before you establish AC power. It is, first bullet point there, it is accomplished prior to establishing AC power. It affects items which could affect safety of personnel or items which could affect equipment conditions. So this is the reason you're doing the safety check. It is a read and do procedure. It's not done from memory. Most things in the jet are done from memory and backed up with a checklist. But the electrical power up and the electrical power down are two areas that are done by checklist, by read and do, and not from memory. They can be done by the captain or the first officer, and it can be done also by the captain and the first officer. In other words, the first officer could read the procedure and the captain could do it, or the captain could read the procedure and the first officer could do it. Or the captain can do it all himself, or the first officer can do it all himself. Again, it's up to the airline's SOPs, and in some cases it's left at the discretion of the captain and or FO. Here's a checklist that I use. It's Subsonic Flight Training, and the normal checklist has it as a safety check. You can see the safety check consists of turning the battery switch on, the standby power to auto, the hydraulic demand pumps off, windshield wipers off, alternate flaps off, landing gear lever down, flap lever and flap indication agree, and the bus tie breakers are in auto. So you can see the first items we check here would be that the battery switch, we're going to turn that on. That is a guarded switch, so we'd have to lift the guard and push the switch. That's in red. And then the standby power would go from the off position to the auto position. That's in blue. And then we'd make sure the hydraulic demand pumps are all off. That's in green. And then we'd make sure that the windshield wiper switches are off. That's in yellow. And why do we do the demand pumps and why do we do the wipers? Well, the demand pumps, if they're on, possibly hydraulics could activate and something could move. We don't want that happening when we establish AC power. If the wipers aren't off, if we have them in low or high and we establish AC power, the wipers could start to move. And on a dry windshield, they could scratch the windshield and do some damage. So this is the reason we're doing these. Are safety items that as we establish AC power, we want to make sure it's safe to do so. And then we'll come down to the alternate flap selector to make sure that's off. That's in blue. I will group these switches, so I'll check the alternate flap selector is off, but I'll also check the alternate flap arm switch is off as well. So I'll check both those switches, even though the checklist just has you checking the alternate flap selector, that it's in the off position, because the flaps won't move if that's off, even if the arm switch is armed. But normally good to check both of those switches as one. Landing gear lever should be down. And the flap lever and flap indication should agree. In this case, the flaps are up, so the indication should agree with the flap lever. We'll see that in the virtual simulator. And then if we go back up to the overhead panel, we would check that the bus tie switches are all in auto. And those were highlighted in the previous slide, and we'll show you that in the virtual simulator. Once the safety check is complete, Then we can establish AC power by starting the APU. Once the APU is up and running, we could select APU 1 and or APU 2, or both. And if we have external power connected and the frequency and volts are good, then we could establish external power by selecting external 1 and or external power 2. Once we've established AC power, then we'll go ahead and do the preliminary pre-flight procedure. This is done from memory. Either pilot can accomplish this. Usually it's the captain that does it, but the first officer could do it as well. It's checking equipment prior to doing your FMS CDU pre-flight, and it's checking equipment prior to doing your captain and or first officer scan flow as well. And once the preliminary pre-flight procedure is complete, then one crew member, either the captain or the first officer, would do the FMS CDU pre-flight, and the other crew member would start on his scan flow, whether it be the FO or the captain. The preliminary pre-flight procedure consists of bringing the IRUs to the nav position, going from off to nav. Once we've done that, we check the status page. There's 3 things we're going to check on the status page. Well, actually 2 things on the status page and 1 on the engine page. On the status page, we're going to check hydraulic quantities, that they're sufficient. 1.00 would represent a normal service level, is at 1.00. And so this is a percentage, and it's not gallons, it's not liters, it's just a percentage of the normal service level. So when you see 1.08, it means it's 108% of the normal service level. The normal service level is set at 1.00, and full is up actually around 1.18, 1.19. So you can see anything that's 0.99, it's it's slightly below the normal service level. Anything that's above it is above the normal service level. The refill indication comes at 0.75 or less. So as long as you don't see an RF there, you have enough hydraulic quantity. And normally you're going to see usually you see 101, 102, 103, 0.99 like you see here, something like that. We'd also check crew oxygen and passenger oxygen pressure, that it's sufficient. There are charts in the performance manual in terms of adequate PSI for the crew if you have 3 or 4 crew members on board, and based on altitude and temperature what the minimum PSI is. But if you see 1800 PSI, that's more than enough. Usually you don't have a problem until you're under 1000 PSI. Typically you're going to see, like you see here, 1830, 1850, somewhere in that range. That's certainly adequate. We'd also check engine oil quantity as well on the engine page. That's not shown here, but we'll show it in the virtual simulator. Once we've done that, we'll check the aircraft logbook, make sure the logbook is clean, no outstanding write-ups, and if there's any MEL items, we'd address those. Next thing we're going to check is the P7 circuit breaker panel. That is on the overhead, that's above the overhead panel. The P7 circuit breaker panel consists of a bank of circuit breakers. There are some that are guarded or collared as well, so we would make sure all these are in. We'll also check emergency equipment. Most of it's located in the behind the captain's seat. To the left, there's a sliding door. Opens from bottom to top, and in there you'd find things like the washer fluid, halon fire extinguisher, oxygen. The crash axe is usually mounted, depending on the airline, it could be mounted on the wall on the flight deck. And of course you check whatever other emergency equipment per specific airline, life vests and flashlights and smoke goggles if you have them, PPE equipment, things like that. We'd also check the crew overhead hatch to make sure it's closed and latched. There usually is a cushion there to help insulate from noise. we could pull that down and just make sure it's in the that the handle's in the lock position. Well, I'm not sure why I forgot to include these, but we're also checking the emergency escape devices, or what we call the reels. They're inertial reels. We use them to egress from the aircraft through the crew overhead door, and then they will provide a controlled descent rate through an inertial reel to allow you to descend from the flight deck to the ground in the case of an emergency evacuation from the airplane via the flight deck. Usually there's 5 or 6 of these reels in the stowage compartment that you're checking. We're also going to check the smoke evacuation handle. That's the small blue triangle there that it's in. And we'll check that the overhead maintenance panel is checked, and we'll talk about that in the virtual simulator. On the overhead maintenance panel, we'll also check that the EPU start switch is in TR, and we'll check that the P6 circuit breaker panel is all checked. And then if we're going to check the brake wear indicator pins, we'll make sure the parking brake is set. And we'll show all this in the virtual simulators. Let's go to the virtual simulator now. Okay, we're in the virtual simulator now. And notice the airplane is cold and dark. All the display units are blank. Both CDUs are blank. The ISFD is blank. And the mode control panel has the defaults of, when it's unpowered, of 200 knots on the indicated airspeed Mach window, 000 or north on the heading, and 10,000 feet on the altitude. We go up to the overhead panel. We'll start the safety check. First step is to check to make sure the battery switch is on. So we'll lift the guard and turn the battery switch on. When you turn the battery switch on, some lights come to life. The only light that I don't think is correct is the system fault light. Usually you don't see this in the airplane or the simulator, the real simulator. If we go to the lower forward instrument panel, you'll notice that the ISFD has been powered now once you turn the battery on. The speed and altitude indications just came up, and the attitude starts its initialization process at 90 seconds and counts down. At the end of 90 seconds, attitude will be displayed. We'll go back up to the overhead panel. After we turn the battery switch on, the next step in the checklist is to bring the standby power selector to auto. So we'll do that. We'll come back down to the forward instrument panel, and we should see the captain's PFD and ND come to life, along with the upper ICAS. These 3 display units will come alive when you go standby power to auto. And the left FMC and the left CDU will also come alive as well. So we'll see that in a second down here. And we should see that come alive here. There it is. Let's go back up to the overhead panel. After you turn the battery switch on and the standby power to auto, the next step is to check that the demand pumps are all off. And so we'll come down here and check number 1 off, 2 off, 3 off, and 4 off. Want to make sure these are off so that there's no inadvertent hydraulic movement once you establish AC power. Next step would be to check that the windshield wipers, the switches are off. In this case, the left captain side is off and the right first officer side is off. We'll go back down to the forward instrument panel and check that the alternate flaps are off. And not a bad idea to check that the alternate arm switch is also off as well. This prevents, again, any inadvertent movement that could occur when you establish AC power. We'll check that the landing gear lever is down, and you have a down and green indication. Then we'll check that the flap lever and the flap indication both agree. If we go down to the flap lever, we can see that the handle is in the up position, And so we are going to check that the indication says up, which it does, and that it's in green as well. Let's go back up here. You can see that and this is a normal indication, that the left side transmitters are not powered, so you have amber X's on the left side transmitters. That's a normal situation when you're in standby power. The leading edges are showing that they're retracted. The right side position transmitters are powered. They're showing that the trailing edge inboard and outboard sections are up. And as long as you see the green up indication, you know that everything agrees with the flap lever. Now, if you happen to see that this was magenta, and maybe it said up, but some leading edges were out, then we'd want to contact maintenance or contact ramp control or our ground personnel in the nose, and just make sure the area around the leading edge and trailing edge flaps are clear before we establish AC power, so that when we do, and if flaps start to move, they aren't going to do any damage to anybody or anything that's outside the aircraft. But in this case, the flap lever and the flap indication agree, so that's good. And then we'll go back up to the overhead panel and check that the bus tie breakers are in auto, which they should be. Auto, 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 auto. And then that completes the safety check. And then from there we can establish AC power with external or APU. In this case the APU is not running, but we do have external power plugged in. They've plugged it in downstairs. And you can see we have the veil lights, meaning the frequency and voltage are good and acceptable for use. So we can select external power 1. And now we have AC power on the airplane. You can see that equipments and displays will come to life. And if we go down to the forward instrument panel, now you can see that in addition to the captain's inboard and outboard display units and the upper display unit, now the lower display unit is powered. The first officer's inboard and outboard display units are powered, and the right FMC is powered along with the right CDU. So now everything basically comes to life once you have AC power on the airplane. If you're a freighter, we're going to leave it just as it is, which means that we'll have external power 1 on, the split system breaker would be closed, and more importantly, the main deck handling bus will be powered because external power 2 is available. This means that the cargo loaders then can operate the main deck handling bus and the equipment that's on that bus that allows them to load the main deck cargo area and operate the equipment. If we were a passenger airplane, we really don't care because we don't have a main deck handling bus. And the lower lobes, forward and aft lower lobes, are powered by external 1 or APU 1, and we have that on right now. So for a passenger airplane, we can select both of those at this point, external 1 and external 2. If we were on the freighter airplane and we did this without having the APU started, then they'd probably be yelling at us to power the main deck handling bus so that they can load the aircraft, and then we'd either have to start the APU or we could take external 2 off again and allow external 1 to power the synchronous bus and just keep this available. So again, depends whether you're a passenger or a freighter. We're a passenger airplane today, so we're going to go ahead and select external 2 on. Now that we have AC power on the airplane, the next step would be to adjust our lighting. Usually, if it's usually a darkened environment, so we would normally adjust all our lighting. We'll cover that in another module. Then we're going to start the preliminary pre-flight procedure. So the first step on that is to take the IRUs, the IRSs, the IRS system, and take the individual IRUs and bring them from off to nav. We do that by pulling the switch out and rotating it to the right through the align position and to the nav position. So we'll do that now. You go from off to nav, off to nav, and again, if you're in the airplane or the simulator, you have to pull this switch out and rotate it, and off to nav. And that'll start the alignment process. If we go down to the forward instrument panel and we take away some of these ICAS messages, you can see that we have IRS align mode right, IRS align mode center, and IRS align mode left. And you can also see in your ND that you have your time to align. And normally what you're going to see there is that it would start at 7 minutes and then count down from 7 minutes. Not sure why it's zeros here, because normally we'd see 7, and then when it gets to about 7 minutes prior to alignment, it would start to count down. Now, typically at the mid-latitudes, it takes about 10 minutes for the IRSs to align. And during this time, we would want to move the airplane. And of course, we'd have to go and give it our present position. Just for the heck of it, in the PMDG, let's go ahead and give it a GPS position. Let's see if that... there must be an option in here, and I haven't discovered it. That immediately did the alignment. So there might be an option in there to make the IRU alignment go fast and not have to wait the 10 minutes. And that's what I suspect just happened. I'll have to find that. It's probably in there somewhere. There's probably an option to make it a realistic 10-minute alignment. And then you would have seen 7 minutes here. Because when I put in the GPS position, it aligned right away, like we had just gone through the 10 minutes. So, going back to the overhead panel, we brought the IRUs to the nav position. That's the first step. And then we're going to go check our status page. So we'll go back down to the forward instrument panel. We'll go to our display select panel, select status. We'll bring up the status page, and then we can see here that we have our hydraulic quantities. We're going to check that they're good. We talked about that. Anything above 0.75 will not show an magenta RF next to it, indicating refill. In this case, anything 0.95 or 98 or 1.03 is all sufficient. We'd also want to check our crew oxygen pressure and our passenger oxygen pressure to make sure they're sufficient for the flight. And then the one thing we didn't show previously was going to the engine page. This would be the secondary engine page, and checking oil quantity. And here we'd make sure that the oil is sufficient for the flight. Typically, in this case, this is in quarts. You'd normally see 25 quarts or 23 or 22 in that range. Some airlines will specify a minimum oil quantity for dispatch. Others will not. And just, as long as you're up somewhere 20 to 25, you're fine. If it gets too low, it will turn magenta. The engine can operate actually on very little oil. But normally it's serviced and it's up there at the higher levels normally. So we check those three things: oxygen pressure, actually hydraulic quantities, pressures for oxygen, and then oil quantity on the engine page. So two things on the status page, one item on the engine page. After you've done that, we'll check the logbook. Of course, we don't have that on the PMDG, but we'd normally check the logbook, make sure it's clean. If there's any MEL items, we would have to address those at this time, but again, captain's duty normally to check that. Then we're going to check the P7 circuit breaker panel. The P7 panel is right above the overhead panel. And we'll scroll up there and take a look at it. So right up here above the overhead panel would be the P7 circuit breaker panel. It's a bank of instruments, or bank of circuit breakers, and again, like we said earlier, we'd make sure all these are in. In the airplane or the simulator, you'd actually have to turn down the lighting for these normally to check them, because you're kind of looking down at them, and all the little white lights of the circuit breaker lighting would usually stare back at you, and it'd be hard to tell if one is out, because when it's out you'll see the white body of the circuit breaker. And in order to check them in, we usually have to turn the lighting down, and then even take a flashlight and shine it down the circuit breaker panel to see if one is out. Very easy to miss one that's popped, so you have to be careful. After we check this P7 circuit breaker, we're going to check our emergency equipment. The emergency equipment is, again, pretty much an option by airline what you're checking. But if we can swing around here, we might be able to see. Let's go back here. And let's see if we can see what I want to see. Now I'm just kind of backing up on the left side behind the captain's seat. That's the observer's, one of the observer's seats we're looking at. We're just going to kind of go behind his seat, and we see that there's a, looks like an old roll top type desk that opens from the bottom to the top. And when you open this, this little desk, or whatever you want to call it, cabinet, when you take that from the bottom to the top, it'll open. And inside there you're going to find things like the washer fluid for the windshield, portable oxygen bottle, halon fire extinguisher, things like that. The crash axe is usually located on the sidewall or wall of the flight deck, and not usually in here. It could be in here, but it depends on the airline. Normally they're on the side walls. And of course, any other equipment that you need to check, like life vest. There's a little pouch here where you pull it out. Your life vest is in this little pouch. Flashlights, PBE, protective breathing equipment, smoke goggles if you have those. Anything your airline has you check, we'd be checking the emergency equipment at this time. Then we're going to check the crew overhead hatch, and that's going to be up. We can get the right key to go up. We'll see the overhead, and you can see that notice there is an arrow pointing to the crash deck, so it looks like they either have it, not sure if it's on the sidewall here or in the compartment. But you can see the PBE, the crash axe, and the halon probably all located within that stowage area. If we keep going up, we'll see the crew overhead hatch. You can start to see the cushion for it. And let me back out a little bit so we can see it a little better. That is a cushion that helps for sound, so that it's not too loud on the flight deck. It's a sound cushion. You have to actually pull that down, and then you can see that the handle is closed and latched, and we want to check that. Normally after that, we're going to check the smoke vent handle. And if you happen to remember seeing it here on the circuit breaker panel, on the P7 circuit breaker panel, there's a smoke vent handle that's right here, and we want to make sure that that is pushed in. PMDG, you can actually pull it out. You don't want to leave it that way, because on takeoff it'll get really loud on the flight deck. What this does is open a small port. It used to be the old Celestial port on the 747. On the 747-400, the Celestial port is used as a smoke port. And so what that does is open that little smoke port, and a differential pressure then would cause the air to flow out of the flight deck and remove any smoke that perhaps is accumulated on the flight deck in an emergency situation. So we're going to make sure that's in, which it is. And then we'll check the overhead maintenance panel. The overhead maintenance panel is just above, you can see it right here. And what we're going to be checking here is primarily that all the guards are closed and that all the lights are out. The only light you may see is the one we see right here, and that is the split system breaker open light. That's because we're not a freighter, and so we have external 1 and external 2 on the airplane. The SSB is open, and so we have the SSB open light. That's a perfectly normal situation. But notice all the other lights, APU, engine field off lights, flight control, shut-off switch, valve lights are all closed. The IRS on battery light is extinguished. Everything's extinguished. This is the only light you would expect to see up here. If you happen to see one of these, like perhaps you're doing your overhead maintenance panel, you see one of those guards open, and the switch is in the position you see, and you have a valve closed light illuminated, that would indicate that a hydraulic shutoff valve is not fully open. It's either partially closed or closed. And if we happen to be doing this and we saw that, we'd contact maintenance. They could be working on the airplane. If you were just to flip that guard and close it, you could end up doing some damage to personnel and or the airplane. In this case, we wouldn't want to go with that. We'd have to ask maintenance why it's in that position, and then they'd probably come up and they'd be the one to reposition that. So we'll go ahead and do that now. We'll close the guard, and then the hydraulic shutoff valve will open fully, and then the light extinguishes. And that's the way we want it. Usually the cockpit voice recorder in the squib test is a maintenance function, so this is normally done by maintenance. They can check the squibs, and it's usually not a flight crew function. Again, it depends on airline, but most airlines have it as a maintenance function, not as a flight crew function. So we check the overhead maintenance panel, and then the next thing we do after that is one more item on that would be the APU-TR start switch, TR or APU battery. You want to just make sure it's in the TR position. That's the normal position that it's left in if you have that switch. And then we check the P6 circuit breaker panel. P6 circuit. I'll kind of move forward so you can see that here's the first officer's area right here. That's his seat coming up. You'll notice that the P6 circuit breaker panel has these, you can see these clear guards on here. You have to be very careful when you put your flight bag in if you're the FO, because when these guards weren't there, it'd be very easy to clip a circuit breaker with your flight bag. So they put these clear guards on here to protect against that. You can actually still do it. So you have to be, usually you tell the FOs you want to put your bag over your chair and down and not come in sideways and possibly clip a circuit breaker. So you do have to be careful here that you're not clipping any circuit breakers, but we're going to want to check the P6, make sure they're all in. And then we want to move up from the P6 circuit breaker panel and check the escape devices and make sure the proper number of reels are in the stowage container and that they are hooked up to the aircraft structure. Usually there's 5 of these. There could be more, but the normal amount is 5. And then if we're going to check the brake wear indicator pins, we're going to set the parking brake. And so if you're going to do your walk around and you want to check the brake wear indicating pins, then we'll go ahead and come over here. You can see it. There's the parking brake. And we can set the parking brake. So we'll go ahead and do that now. We'll get a memo message saying parking brake set. And then we could, if we desired to, we could check the brake wear indicator pins at that time. This is all done from memory. It's the preliminary pre-flight procedure. Once you're done with that, then normally depends on the airline. Some airlines have the captain or the pilot flying do the FMS CDU pre-flight, and then the other pilot will either be walking around the airplane or conducting his interior scan flow. So that completes the safety check, which is establishing AC power, and once you're done with that, doing the preliminary pre-flight procedure, and once you're done with that, we're ready to do the FMS CDU pre-flight and or the first officer or captain scan flow procedure, which we'll cover in another module. Okay, let's lower the HUD and go flying. Until our next briefing, keep the blue side up. Captain Al, out.